Hi everyone, welcome back to this Unity tutorial series on how to create a roguelike like Vampire Survivors. So, stats make up a huge part of Vampire Survivors just like any other game. They define many things such as speed and attack or defense and health. Now, if you recall back to the previous part, we have already created some stats for our weapon and enemies while working on their respective scripts. However, these aren't really that expendable and they kind of a nuisance because we always have to reference back to a script whenever we want a stat of a weapon and enemy per se. Additionally, testing will be a lot harder because we have to create two of the same prefabs to compare a batch of values. Now, for the most part, you might think that this is a minor issue, but as you get more into creating new weapons and enemies and your game expands and grows bigger, you will soon realize that it is better to have a more convenient way to test different values. So, in today's part, we'll be taking a look at how we can create scalable weapon and enemy stats, and also touch on how we can make use of weapon stats to damage enemies. And by the end of this part, you should have something like this. So you're gonna have weapon stats, enemy stats, and of course a way to damage enemies using weapons. And without further ado, let's begin. So let's start with creating stats for our weapons that we made in the previous part. Now, before we begin creating any form of stats, we have to first understand what we are trying to achieve. And we basically want something that is easy to add on to, a data container, and something that makes testing easier. Now, luckily for us, Unity already has something built in that fits all three of our needs, and that is scriptable objects. Now, if this is your first time hearing or working with scriptable objects, I highly recommend you check out Brecky's or Samyam's video on them. They are both extremely informative and teach you the ins and outs of how to use scriptable objects. However, for the sake of this tutorial, I'll still give you the basic rundown as to what exactly they are. Now, scriptable objects are pretty much just data containers used to contain data that we need for the game to function. You can think of them as templates for objects, and they are most notably used to store stats like the ones I mentioned previously, like speed and defense or health. But the biggest difference between storing stats in a script, which is a mono behavior, and a scriptable object is that scriptable objects are actually an asset. This means that they are stored within your assets folder as a project level asset. Now, this makes them more convenient because we can actually duplicate them and test them for different stats. Scriptable objects are also independent from anything else within the game, and since they are independent, any game object within any scene can access the scriptable object, which makes it convenient for referencing data. So what this means is that there won't be any need to reference a certain script or certain game object, which is extremely convenient. Now, what this also means is that if you were to play the game and change a value of a scriptable object, because it is an asset level object, a project level object, the value will be saved. So this is very different from a prefab, as a prefab only saves the value after stopping play mode and not during play mode. Now keep in mind, because this is a very important point that we will touch on later on. Okay, so I could actually go on and on about scriptable objects and their various benefits, but for the sake of simplicity, let's just dive right in and you understand what I'm talking about. First up, create a new C# script called weapon scriptable object inside of the weapon subfolder in scripts and open it. By default, all scripts in Unity derive from mono behavior as it allows the script to be a component of an object. However, since we want a scriptable object that doesn't sit on a game object, we just have to change this to scriptable object, if you recall back to the previous part about inheritance. Make sure to also delete away the start and update functions since we have no need for them. Now, if you take a look at the weapon controller script that we created in the previous part, you should see that the stats that we created for the weapon previously. Now, let's copy over all the variables that won't change during runtime. Now, this is because scriptable objects, as I said previously, they save the value during runtime and thus the variable will not be reset even when the game is restarted. Now, all that's needed is to define a way to create a scriptable object from this template in the assets folder. And there's a very simple way to do this. We just need to add an attribute called create asset menu to the class. Now if you head back to the editor like this and just right click on the project window and go to create, it should show up as your first option. Although this works fine, for the sake of organization, let's add a few more properties to the attribute. Let's set the default file name when creating a new scriptable object to be weapon scriptable object, and the menu name to be something like scriptable objects. However, since we are going to be creating more scriptable objects for enemies and even the player down the line, it will be better to create a submenu by going scriptable objects/weapon to basically just differentiate it. We can now save this and head back into the editor. Create a new folder called scriptable objects, and inside there, if you right click and go to create, you should be able to see that the scriptable object has been sorted. Now create two new weapon scriptable objects and rename them both to knife weapon and garlic weapon respectively. If you look towards the inspector while selecting one of the scriptable objects, you should see the stats that we created within the script. Now it's time for us to link the stats to the relevant weapon scripts. Open up the weapon controller script, and inside here we just have to create a new public variable of type weapon scriptable object and name it weapon data. So this variable will actually be assigned through the inspector, as you might have already known, and will serve as a reference to all our stats. Next, we have to just remove all the variables that we copied over to the weapon scriptable object script because they are useless now. Now, before this, I actually recommend you head back into the editor and save a screenshot of your values in the knife controller and garlic controller scripts beforehand, because we have to actually reassign them later on. So it won't be a hassle to remember them. There should now be a ton of errors showing up in your console from the weapon controller, knife controller, garlic controller, and knife behavior scripts. So let's just open them up and fix them one by one. For the knife behavior script, we can actually remove the reference to the knife controller since now we no longer need it. Instead, let's head over to our project weapon behavior script and also add in the same public variable called weapon data. We can also do the same for the melee weapon behavior script for future use. Now in the knife behavior script, let's simply reference the newly created weapon data. So if you head back into your editor now and look towards the knife controller or garlic controller objects, you should now see that a slot has appeared. Now the same thing should also happen to the behavior scripts on the different prefabs. So let's just simply drag and drop their respective scriptable objects inside. Now let's assign the values of the parameters in the scriptable objects. So I'll just assign my previous values to the knife weapon and the garlic weapon. Hit play and test to make sure everything is working as intended. Now, as you might have been able to tell already, if we want to test a whole new set of values, we can now just simply duplicate the scriptable object and change the values before assigning it. This will make testing a whole lot easier. Great. Now that we're done with the weapon stats, it's time for us to move on to creating the enemy stats. Now, similar to how we did so for the weapons, let's also make them scriptable objects. What I mean is enemy scriptable objects, so that everything in our game is consistent. We don't want to be using scriptable objects to store stats for one thing, and then we go back to using mono behaviors to store stats for another thing. It just doesn't make sense, and it will become very confusing very fast and turn into spaghetti code. So let's just create a script called enemy scriptable objects and derive it from the scriptable object, obviously. Next, we just need to create some stats for the enemies, like how we did with the weapon scriptable objects. And obviously, we need the way to create it, so let's just create an asset menu for it. Now head into your scriptable objects folder and now create an enemy scriptable object and name it bad enemy. Next, create two folders and name them weapons and enemies and drag the respective scriptable objects into the folders. Open the enemy movement script, and then we just need to create a new public variable with type enemy scriptable object called enemy data. Now, since we created the stats for the enemy in the enemy scriptable object script, we can remove the move speed variable here and just reference the enemy data stats. Head back into the editor, and then we can just assign the bad enemy scriptable object to the bad prefab. Afterwards, just assign the previous move speed value that you have for the bad inside the bad enemy scriptable object. As mine was 2, I'll just set it as that. As per usual, hit play and make sure everything is working good before moving on. Okay, so before we move on, there's actually a very important thing that we must do, and that is creating properties for our stats. Now, properties, also known as getters and setters, encapsulate member variables such that we can make them read or write only. Now, you might have heard of them already, but I'll just elaborate more on them. So currently, all our variables in our scriptable object scripts are actually marked as public, which allows us to access them in other scripts. This is great and all, but there's actually a very fatal flaw in this. I don't know if you noticed, but it is very easy to accidentally write to a variable of a scriptable object. Now, you might think that this is a small issue, but you have to remember that scriptable objects saves values even during runtime and do not reset afterwards. This is very dangerous as values can be modified even without your knowledge. So if you don't check the scriptable object, something may go wrong. So properties will act as a failsafe so that such things don't happen. They give us a wider range of control of when and how a variable is accessed, so we don't unnecessarily access data. Now, for more information on properties, you can actually check out Unity's official tutorial on how to use them. Now, within the weapon scriptable object script, let's start creating a property of every single field here. Now, we can begin with prefab and work our way down the line. So first things first, we need to remove the public keyword, obviously, and then add a serialized field attribute above the variable. So what this does is that serialized field allows you to serialize, the private variables. And then next up, we need to create a new public game object called prefab with a capital. Now, it is always good to use the same name for properties, but with a capital letter just to differentiate them, because we don't want to name them something completely different. That will make it extremely hard to tell what is what. And now we can just create a public getter and a private setter using the lambda operator. This will allow us to just shorten our syntax. Now, if you haven't worked with the lambda operator before, do not worry. You don't need to know anything about it. You can just follow it. This is just solely to just shorten our syntax. Okay, so the reason why we are creating a public getter and a private setter is because obviously we just want to read from the variable itself, and we definitely don't want to set the variable. I recommend you head back into your editor and save a screenshot of the values in the scriptable objects. But technically speaking, it shouldn't be an issue since Unity should save the index values already. Now that you have the gist of it, let's do the same for the other variables as well. And by the end of it, you should have something like this. Now when you try to write to one of these variables, you will receive an error. Awesome. Now let's fix all the errors that arose because of this. Let's also do the same for the variables in the enemy scriptable object script. Then let's fix the error that arose because of this. Now it's time for us to finally create a way to damage enemies and weapons. We already have the stats in place, so all that's left for us is to create a system that makes enemies lose health when they get hit by weapons. Let's create a new script called enemy stats that will be used to handle all the enemy stats. Inside here, we want to create a reference to the enemy scriptable object, create variables for every single variable in the enemy scriptable object script, but with the prefix of current, except for max health. So we can give that the name current health. Now, these will be used to track our current values, which might change midway through the game due to some effect. And since we can't write to the variables of scriptable objects, these variables are a necessity. Now, I'll give you an example. For instance, the player might receive a buff that slows down all enemies, right? And thus the current speed of the enemy will need to change, since we can't write to the move speed itself. Now remove the start and update functions and then create an awake function, and then we just have to assign these current sets to be the value of the ones that we set in the scriptable object in the awake function. Now we are using awake because it calls before start and thus is more reliable. Now, we just need a public function called take damage now, which is used to make the enemies lose health. Inside take damage, we simply want to create an argument of type float called damage and reduce the current health by damage. Afterwards, let's just check if the current health is less than or equals to 0, and obviously if it is, let's just kill the enemy. So we just create a new function called kill, which just simply destroys the enemy when called. Alright, great. Now this will basically allow us to input the amount of damage to be dealt to the enemy and check if the enemy should be dead every time damage is inflicted. We can leave this be for now and expand on it later on. Now it's time to detect enemies and determine how they take damage. We'll begin with the projectile weapon, which is the knife weapon, before moving on to the melee weapon. So the easiest and simplest way to do this would be just to check if the collider on the weapon is touching the collider on the enemy and apply damage afterwards. So let's add a polygon collider 2D to the knife weapon prefab and drag it into the scene. Now make sure to set it to be a trigger as well. So the reason why we're using this collider instead of any other collider is because we want to be as accurate as possible. If you use a box collider 2D, you would see that there is no way we can be accurate due to the sprite orientation of our knife. We're also editing this in the scene because editing the polygon collider in the prefab causes it to autosave, which makes the process a lot slower. So it's just much better to edit in the scene and make it a new prefab later on. Now in the scene view, edit the collider such that it takes the shape of the knife. Click the Edit Collider button within the inspector and drag the points to match the shape. You can also add more points by just clicking and dragging anywhere between two lines. Now set the freeze rotation on the Z-axis to be true, and obviously just drag the knife weapon in the scene to the prefab folder and make it an original prefab. Now you can delete away the old prefab and rename the new prefab appropriately. Once that's done, make sure to set the new prefab to the prefab slot on the knife weapon scriptable object. Let's start applying damage for the projectiles first. Open up your projectile behavior script, and in here we want to do something similar to what we did in the enemy stats. Create variables for every single variable in the weapon scriptable object script with the prefix of current except for the prefab. Now make them protected such that they can be accessed by the classes, and these will be used to track our current values. Now create an awake function, and then we just have to assign these current stats to be the values of the ones that we set in the scriptable objects in the awake function. Now let's create an on trigger enter 2D marked with the keywords protected and virtual so that we can override them if needed. And inside the function, let's just check if the collider that the projectile collided with has the tag of enemy, and afterwards, reference the enemy stats from the collider and apply the damage to the enemy. Now make sure to use current damage instead of weapon data.damage in case of any damage multipliers that are going to be applied in the future. And then head back into the editor to set the damage and max health of the knife weapon and the bad enemy scriptable objects. I'll set mine to be 5 and 10 respectively. Now before you press play, make sure to create a new tag called enemy and apply it onto the bad prefab along with the enemy stat script. Now when you play the game and shoot at the enemy, you will see that it disappears after being hit twice since its health is depleted. Awesome! But we are not quite yet done for the projectile behavior, because as you can see in the scene, the projectile doesn't get destroyed when hitting an enemy, but only when the destroy after seconds time is up. Now that's where Pierce comes in. As explained in the previous part, pierce is basically just the maximum amount of times a weapon can hit before it gets destroyed. Now, we can use this stat just to determine the amount of times a projectile can pass through an enemy before being removed. Let's create a function called reduce pierce, and inside it, decrement the current pierce. And afterwards, let's just check if the current pierce has reached 0, and if it has, let's just destroy it. Call reduce pierce at the end of the onTriggerEnter2D function as well. Now back in the editor, set the pierce of the knife weapon to be 1 and hit play. You should now see that the knife projectile disappears after touching the enemy. Now for the garlic weapon, we can simply add a circle collider 2D because of the shape, and it should auto scale to our sprite. Make sure to also set it as a trigger too. Next up is to open the melee weapon behavior script and do the same for what we did previously in the projectile weapon behavior script. Head back into the editor and set the damage of the garlic scriptable object to be something like 5. Afterwards, you can just disable the knife controller game object and the enemy movement script on the bed to just make testing easier. Hit play and just move towards the enemy. Alright, now we have a way to damage enemies using garlic. Awesome. So although this is great, you might have already noticed there is just one minor issue with this, and that is if you move away from the enemy and back to the enemy, you can just immediately just deal damage to it over and over again. However, in Vampire Survivors, the garlic does, well, the following. As it says here, the damage will be dealt instantly to an enemy if they have never been in the circle before, after which they cannot be hit by it again until garlic's cooldown is over, even if they temporarily leave its area. So this is from the Vampire Survivors wiki. So in order to make the behavior of our garlic similar to the one in Vampire Survivors, we must do a few things. So inside the garlic behavior script, override the onTrigger2D function, and we don't have to call the base for this, as we want to access the local variable of enemy, which is not possible if you call base. So we have to copy over the entire function. So create a new list of game object called marked enemies and initialize it in the start function. Now let's add a new condition in the onTriggerEnter2D's if statement, checking if the marked enemies list contains the detected object. If it does not, we shall allow it to run. Now at the end of the function, after damaging the enemy, let's just add the enemy to the marked enemies list. So what this entire system allows us to do is basically just to detect the marked enemies that the current spawn garlic has hit and make it such that they won't be able to be damaged by the same garlic again. This more or less matches up with what Vampire Survivors has done. Now if you're wondering why we didn't just call the base function and then just reference the local variable of enemy from there, it's because, well, it is not possible to do so. So we just have to go through this, well, again. But it doesn't matter because this is much better for us since we want to actually edit code within the lines of the base. So with that said, hit play and test it out. Everything should work just fine. So that's all for this part. In this part, we went through how to create stats for our weapons and enemies, including damaging enemies with weapons. I hope you all enjoyed the video, and if you want to support what we do, you can actually help us by becoming a patron. This will give you access to the project files for tutorials, like this one, as well as any Patreon exclusive posts on our blog. You can find the link to this in the description below. Any support that you give us will actually go a long way, because currently we are making back about 20 cents for every single dollar that we put into content creation. So your help will actually go a long way to help us make this a sustainable endeavor. So that's all. I'll see you all in the next part. Bye.